We are continuing with the isomerism, बच्चों. We are continuing with the isomerism, and the first type was the structural isomerism, in which we said that compounds having same molecular formula, but the different structures are known as structural isomers. And then we said that how the structures differ from each other. They differ by means of three different types, right? Yes. So structural isomerism, first of all, when the structures differ, but the molecular formula is the same. Today we are going to see how the structures differ, right? There are three types in which the structures differ by means of chain, position of functional group, and functional group, right? So today we are continuing with these examples, how the structures differ, right? Let's do the examples group wise, okay? Number one, alkane. Okay, first let me put a question like this. Please, everyone, please write a question. Draw all. Here is the question. Please draw all possible. Please write this question. Draw all possible structural isomers. Which structural isomers? Chain and position. In some cases, maybe functional group, but chain and position isomers. Draw all possible structural isomers, and structural isomers में कौन से आपने focus करना है? Chain and position. Let's start with alkanes. If I ask you, okay, alkane C4H10 एक molecular formula के साथ, how many structural chain and position isomers are possible for this? I'm going to tell you a procedure that first of all, when they ask you to draw the all structural isomers, the first of all, what you have to do, yes, you have to write the full carbon chain, whatever the number of carbons you have, and that'll be the first isomer. And if there is a functional group, just put in the functional group. As alkanes do not have any functional group, so I'm just writing a full carbon chain, right? And in the second step, going from this side to this side, always make chain isomers first of all. Either it's an alkane, alkene, whatever the functional group. If you need to draw all the structural isomers, first of all, draw the chain isomers. And how can you draw the chain isomers? Putting all four carbon in the chain is the first isomer, and then instead of putting all four in the chain, how many? 3 in the chain and 1 as a branch. Okay, and this is the second one. And then you can't make the branch lower than this. The third year हो सकता है कि हम 2 carbon in the chain and 2 in the branch. Branch can't be on the terminal carbon. Na? Now these two are the terminal carbon. If I put 2 carbons here, it won't be a branch. It will be a part of the chain. So what I said, that there is no more chain isomers. Now every time when you have made a chain isomers, then you have to look for the position isomers of these chain isomers as well. And by changing the position of functional group, but alkanes luckily do not have any functional group. So therefore we say they do not have to change the position of the functional group. So in short, there are only 2 possible isomers for C4H8, right? C4H10. Similarly, there's another alkane C5H12. If I ask you draw all chain and position isomer for C5H12, what is the first way? Putting all 5 carbon in one chain, 1, 2, 3, 4, 5. And then putting 4 carbon in the chain, 1 in the branch, and then putting how many carbon in the chain? 3 and 2 as a branch. Now branch on the central carbon pe dono branches. Okay? You can't make chain smaller than 3 carbons, so this is the maximum number which can be reduced. So these are the 3 position isomers for this. Oh, sorry, chain isomers for this. Right? If you think you can give the names, for example, pentane, 2-methyl-butane, and 2,2-dimethyl propane. So there are 3 structural isomers which all of them are the chain isomers with the molecular formula C5H10 and which are all of them alkanes. Yeah, position isomer is only made when the change the position of functional group. So we have no functional group, but here if we want to change the branch position, it won't make any difference because it is 2-methyl butane at this moment. If I move the position of branch to the next carbon, numbering starts from the left side, the same 2-methyl butane is there. C6H14, this is your homework. Please note down. निशान आप भी नोट कर लीजिएगा C6H14 draw all possible chain and position isomers for this. Okay, now come to the alkenes. If I ask you to draw C4H8 all possible chain and position isomer for an alkene having molecular formula C4H8, I always suggest you going to the right, made chain isomers bacho. 1, 2, 3, 4, 4 carbon in the chain. But in this case, everyone, need your attention. First make the carbon chain and then put in the functional group. We have the functional group of alkene, so put it on the terminal carbon this time. 4 carbon in the chain. Now let's make chain isomers. How many carbons? Don't make turn the position of double bond. Just make third carbon as a branch. So ये दो क्या बन गए? Chain isomers, which is butanene. And this is 2-methyl propene. Propene, yeah, propane में आप position ना भी mention करें, doesn't make difference because it always vanene है ना. इस तरफ भी कर दें तो भी propane ही होगा. So there's no point. Now every chain you have to see, is there any position isomer possible? For example, if I shift the position of functional group, that'll be the position isomer na. So for the first one, yes, there is a possibility of position isomer, that is butene. No more, right? उसमें भी अगर आप इसको इधर shift कर देंगे तो आप कहते हैं it remains the same 2-methyl propene, so there's no point, right? So total number of isomers are 3 structural isomers, which includes chain and position. Yes. बाज़ दफा examiners ask you कि इसका कोई functional group isomerism भी है. You know they share their general formula with cycloalkane. तो इसका एक और बन सकता है. What is that? If you put all 4 carbon in a chain and put it in the circle, cyclobutane. So total number of isomers, including chain, position, and functional group, that is 4. If they only ask you, because cyclobutane is also C4H8, na? Iska formula bhi C4H8 ही है. Butane, not ene. Okay. So total number of isomers, including chain, position, and functional group, is 4. Okay. But if they ask you just position and chain isomers, तो वो 3 है. फिर 4 होंगे. Okay. C5H12 का C5H10 का बनाना. Yes, go ahead.
सर आपने क्रॉस क्यों लगाया है? वो 3 वाली
मैंने कहा है कि ये जो चीज है, it is the same thing which is on the top.
ओके.
ठीक है. So it's not a different isomer. वो मुझे कैसे पता चला? मैंने इसका नाम लिखा तो वही चीज आ गई. Okay, let's make all the structural isomers, chain and position for C5H10, which are alkene only. So we'll omit the cycloalkane. Okay. उसने question में क्या दिया? Alkene only. क्या हुआ? पहले we have to draw 5 carbon in one chain. Both of you stay back after the class. I need to speak with you. So this is pent-1E. 1, 2, 3, 4. And this is one branch. Or you can put 1, 2, 3 double bond. अब यहाँ कैसे 2 branches लगानी है? We cannot put 2 branches on the central carbon. Why cannot put 2 carbon? Because carbon 4 से ज़्यादा bonds नहीं बना सकता. So there is a possibility of only 1. So chain isomers are no more. Look at this then. Can you make the position isomer for this? This is pent-1ene. कौन सा बनेगा और? What is the other possibility? Pent-2ene. फिर एक और आगे लेके जाएंगे तो pent-3ene. No, फिर वो नंबरिंग इधर से शुरू हो जाएगी. फिर pentguanine. So there are only 2 position isomers for this. What about this? If I switch it here, वो था 2-methyl butanene. What is this? 2-methyl butanene. Even I can switch it one more here. This will be 3-methyl butanene. 3-methyl butanene. I can't make 3 carbon chain and put 2 carbon on the branches. 5 carbons I have to put now. कौन सा वाला? Which one? Kubeb, the position isomers, first you need to understand the concept. The position isomers कैसे बनते हैं? By changing the position of the functional group. Okay, now I started from here. This one. I switched the position of double bond. In order to just reduce my confusion, or in order to just clear my mind, I was giving name to these compounds. This was 2-methyl butanene.
So you mean that 2-methyl butanene?
Yes, this is 2-methyl butanene.
And then this is 3-methyl.
Just one in. And this is now numbering starts from this side. Na? So this is what? 3-methyl butanene. So are they the different ones? Na? Once you give the names, the clarity is there, because then you can understand, okay, if name is different, obviously the...
So no, we can just use 2 structural isomers, the chain isomers, and then keep taking them into
yes,
position.
Yes, this is how it works. Right? So just like a Rubik's Cube.
Yes.
No, I did not make the position. I make the chain isomer going this side. Aisha, I apologize for inconvenience that is caused, but I have to reduce the number of carbon in the chain. You seems quite upset with this action of mine, that reducing number of carbon in the chain. So 5 ki bajaye, how many carbons I have put in this case? 1, 2, 3, 4. Because I was supposed to make a chain isomer by reducing number of carbon in the chain. Yes, then this is the position for this. This is position for this. No, you just keep changing the position of functional group from one corner to another corner until it is a new compound formed. No, but I gave the names that to make sure ke are these 2 different things or the same thing? Yes. Yes, when I gave the names to them, I was also thinking the same what you are thinking. They'll be at the same position. So once I gave them name, there was clarity. Okay, go ahead.
Can we make 2,2-dimethyl prop-2E?
Okay, now let me make it. Yes, here is propionine. So you want me to put 2 carbon on here, but I can't put the second carbon. Why? Because every carbon has to make maximum 4 bonds. Right? I did try this, and then I crossed out. Okay. Next. Okay, next.
So what if we attach the carbon with the carbon atom for the branch over?
You want me to put the double bond in the branch?
Not the double bond, but the other carbon.
No, that will. Okay, I can do it and prove why I don't do it. Okay, I can do it, and then I'll let you know why I don't do it. Okay, excuse me. You want me to make this 3 carbon chain and then put 2 carbons here, right? Now in this particular case, the chain is not the one that is the straight chain, is this now, because we have to go for the longest chain. So if I number it 1, 2, 3, 4 carbon in the chain, can I have your undivided attention, please? Okay, so this is how many carbons in the chain? 4. So it's a butene, or kaun sa butene? But 1-ene, and is there any branch? At which carbon? Number 2, which is CH3. So it is 2-methyl butanene. So which is already there. ये जो it is also the 2-methyl butanene, ये वाला. Now you see what I'm saying. So whenever you put the branches, don't put 2 carbon in the branch. That's beyond our syllabus goes. और अगर हमारे syllabus में रहोगे तो वो वही चीज बन जाएगी which is already there. Okay? So always put 1 carbon in the branch, and if you have to put more carbon in the branches, so put 1, 1, 1 each time. Okay? Now C6H12 is the homework. Okay, now one more thing. Although we have drawn how many? 5. 5 is the number for C5H10, total number of structural isomers for C5H10, which are alkene. But if I forget about the functional group and I also make a functional group isomer, तो एक और भी add हो जाएगा. Cyclopentane. 5 कार्बन है तो 5 कार्बन ही होने चाहिए ना. तो cyclopentane. साइक्लोपेंटीन में तो 2 हाइड्रोजन्स कम हो जाएंगे ना. साइक्लोपेंटेन. Yes. Next. Okay, C6H12 is your homework. No, वो फंक्शनल ग्रुप आइसोमर होगा. उसमें डबल बॉन्ड है ही नहीं. It's a cyclopentane. This one. This is cyclopentane. Okay, next. C6H12 is your homework. Now let's move on to haloalkanes. Here it is, C4H9Cl. Can you draw all chain and position isomers for C4H9 and tell me the total number?
Total number.
First draw it.
Three.
No. 1, 2, 3, 4. Okay, Dante nahi.
इसको क्या करना है?
There's 2 chains.
All chain and position isomers.
One position is multiple factor. Let's see it. So that's 1 here.
8.
8.
8 isomers.
Maybe too generous. Maybe, but I'm not sure.
तो ये तो बाकी जो सेकंड कार्बन पे लगाएंगे, थर्ड कार्बन पे लगाएंगे, फोर्थ कार्बन पे लगाएंगे. जनरल तो बनते हो जाएगा.
मतलब
सिर्फ 4 ही है.
बहुत ज्यादा बना दिए.
सिर्फ 4 ही है.
6 तो प्रोफेशन नहीं होते आप.
सिर्फ 4.
4.
6.
अब आप तुक्के मारने लगे, मैं खुद ही बनाता हूँ. Okay. I have to draw a 4 carbon chain. 1, 2, 3. This is a 3 carbon chain and 1 in the branch. Okay, now there is no more chain isomer, only 2 chain isomers. Now every chain isomers have to be turned into a position isomer. 1, 2, 3, 4. So Cl moved here. That was 1 chlorobutane, and this is what? 2 chlorobutane. If I even move it further, it won't make a new isomer. On the other hand, I can make changes in the second one. That was 1 chloro 2 methyl propane, and now which I have drawn right now, it is 2 chloro 2 methyl propane. Okay, and one more possible hai. If I switch the Cl position to the extreme left, won't make any change. The first one ही वापस बन जाएगा. So total number is 4. Yes. और आपने तो कोई बहुत ही फराख दिली का मुजाहरा किया था. C4 C4H8Cl2. Can you please draw all possible chain position structural isomers for C4H8Cl2? एक मैं बना दूंगा. I put 4 carbon in the chain and 2 functional group. This time we have 2 functional group. So better put the 2 functional groups at 1 carbon on the terminal.
एक 3 पे रख दें, एक 4 पे रख दें.
वो तो फिर बाद में बनते जाएंगे ना. अभी पहले के लिए I just gave you a food for thought, right? ताकि आपको जरा आसानी हो जाए. Take it as a food for thought and then start. यहाँ से जान निकल रही होती है और तुम लोग मिलते ही नहीं. I think it's too less.
It's more it's
I told it.
सही जो पोजीशन वाले होते हैं इसमें हमें कार्बन को बार बार नहीं करना होगा ना.
No, don't do 2 things one time. Okay? One at a time. Only one at a time. 7. Maybe.
I think it's 7. Yeah.
Okay, now here. Okay, I have the opportunity now. Excuse me. Excuse me. Excuse me. The floor belongs to me now, please, everyone. There are 3 carbon instead of 4 carbon in the chain.
7.
And there's a 1 carbon in the branch here. So this is the only possible chain isomer for this compound. Now I have to go through the position isomers one by one. Now this is again like a Rubik's cube. So I'm going to take this chlorine and move it to the left side 1 step every time. Okay. So it is 1, 2, 3, 4. And I'm also giving names, right? As I'm moving to the left. The first one is 1,1-dichlorobutane. Then it would be 1,2-dichlorobutane. Then it would be 1,3-dichloro. And then it would be 1,4-dichloro. Then it's just like a Rubik's cube. Now take the other one, which is still there on the first carbon, and move it to the extreme left. So will be again 1, 3, 1, 2, and 1, 1. So there's no point. So I'm going to do both of them together. So they were at the 1, 1 chloro, and now they are at 2, 2 dichloro. You missed it. So 1, 2, 3, 4. There is 2, 3 dichloro. Right? So these are all the position isomers for this. 1, 2, 3, 4, 5, 6. Okay. Now these are the position isomers for this chain. Now come to this one. Again, I'm repeating the procedure. Okay. So 1, 2, 3, 1 carbon here. So I moved this chlorine to this one. It was 1, 1 dichloro 2 methyl. Now it is 1, 2 dichloro 2 methyl. I'm going to move it 1 step more to the left. So this is what? 1, 3 dichloro 2 methyl, right? No. Carbon is still in the branch. ये carbon ये देखिए branch में ही है, right? So 7. Now count the total number. I think that's all we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is the total number, I believe, if I'm counting right. 9, na?
Yes, sir.
Okay. Was there anyone with answer 9?
No, sir. You got 7.
7. Which 2 you missed?
Those two, 2, 2, and position isomer in that one.
2, 2, and
2, 2, and 2, 3.
2, 2, and 2, 3.
Yeah.
Okay, next. Here it is. Next is alcohols, बच्चों. Sorry. कौन सा वाला? No, इसमें कौन सा वाला isomer? I just move the position of chloro each time to the left. ये वाला. This one. ये वाला, yes. ये वाला I move to the left, left, left. Every time I moved to the left, one at a time, तो नया isomer बनता गया. बस ये किया मैंने. And then इसके साथ भी यही किया. I took this chlorine and started moving to the left. Okay. Now again, heading देंगी alcohols. No, इसका एक homework है. C3H6Cl2. C3H6Cl2. Okay. Next is alcohols, बच्चों. C3H6OH twice. Can you draw all chain and position isomers which are alcohols only? Which are alcohols only. Okay. जब ये इस तरह का कोई वर्ड यूज करता है तो आप वैसे भी समझ जाते हैं कि इसके शायद फंक्शनल ग्रुप आइसोमर्स भी होंगे. When he specifies, you have to draw alcohols only. Okay. Do it. It's easy, I believe.
तो alcohol क्या करने functionals में नहीं लिखना?
No, chain and position only. Chain and position.
Yes. Now we do.
Yeah, OH twice mean diol है ये. Okay, here we go. There is no chain isomer for this. Chain isomer नहीं है जी कोई. Position isomers again. This is propane 1,1-diol. It could be propane 1,2-diol. It could be propane 1,3-diol. And then it could be propane 2,2-diol. So 1, 2, 3, 4. 4 is the right number. And there is no chain isomer. Fifth one, please guide us. We may have missed one of them. No? Okay, so similarly, next is aldehydes. Aldehydes, C5H10O. Please draw all chain and position, no functional group, okay? Chain and position isomers which are aldehyde only.
Oh, picture. No, this one is only a German carbons. So can you? I think. So aldehyde is only on terminal carbon there.
Sorry?
Terminal carbon is the functional group.
Yes. In aldehydes, we have a special arrangement where we cannot change the position of functional group, okay?
Yeah.
1, 2, 3, 4, 5. All 4 carbon, all 5 carbon in one chain. 1, 2. Position, yes. Branch की position by the way change हो सकती है. 4 and 5. 3 chain isomers. See, I think 2 less. Not 2 less, but the less. Yes. There are 3 chain isomers. Then, as we said, in aldehydes, we cannot, unfortunately, change the position of COOH, the functional group. But what we can do in the middle one here, it is 2-methyl butanol. We can switch its position to make another chain isomer, but with a different position of branch. Here, for example, I take it this one. So it is 3-methyl butanol.
कार्बन चेन का भी वो चेंज कर सकते हैं और सब्सट्रेटों की पोजीशन भी चेंज कर सकते हैं इसमें तो नहीं कर सकते मुझे टर्मिनल
Yeah. No, yeah. In this case,
कभी याद नहीं कभी
no, because you asked 2 contradictory things, so that's why.
नहीं पूछ रही हूँ कि जो पोजीशन आइसोमेरिज्म में हम मिथाइल ग्रुप का भी चेंज कर सकते हैं पोजीशन और कार्बन
Yes.
का भी
Yes. So precisely उसको position isomer we may not be calling it, right? तो हम कह सकते हैं it's a kind of chain isomer because position isomers are precisely when you change the position of functional group. But वो नया isomer तो बन जाता है ना जिधर से भी उल्टा जाए या सीधा, okay? Okay, so aldehydes are next is ketones.
सर इस तरह के सवाल किस तरह आते हैं?
यही आएगा ना जैसे मैं बोलता हूँ कि draw all possible या tell the number of all possible. MCQs भी होते हैं और structured में भी.
Structured में कितने होते हैं सर?
वही 3 marks 2 marks MCQ तो जाहिर है 1 नंबर का ही है. Okay, ketone C5H10O2. Sorry, C5H10OK possible isomers which are ketone.
Ketones are the variable archanes also. I think.
Yeah.
सर इसमें जो OH होता है वो टर्मिनल में नहीं होता ना
CO 1 2 3 4 5 CO is here. अब चेन तो बनेगा ना इसका here और तो नहीं छोटा हो सकता. Here are the chain isomers.
सर आपने पहले में एक्सट्रैक्शन बनाया सर.
Okay, I apologize.
Observations के लिए +1. Oh wait,
सर लास्ट
No, अगर आप in ketones, we cannot put the carbonyl functional group at the terminal carbon because it will turn the ketone into an aldehyde.
सर एक और भी जो
Okay, उधर लगाओगे तो aldehyde बन जाएगा. Yeah. So 1 2 3 4 and 5, yes. As Hashim said, so पहला था pentene 2-on and this is pentene 3-on. 3-on. And what about this? I think we can't change anything in this. So what is the total number? What is the total number? 3. Now, if you notice this thing, examiner asks you, look at this, these 2 molecules. As you know, aldehydes also share the general formula with ketones. Both of them are carbonyl compounds. So you see their molecular formula is the same. So what they do, just to give you an information, the examiners, they ask you, there is a compound with the molecular formula. Now listen carefully. There is a molecule with the molecular formula C5H10O. It has 7 structural isomers.
So
Out of 7, 4 of them react with Fehling solution. Yeah, you will learn this as we'll move. I'll proceed on. Fehling solution is a solution that only reacts with aldehydes. Okay, those who are taking bio, they know, they call it Benedict solution.
Yes.
Yeah, the blue color solution that turns brick red in order to check that sugar is aldehydic or ketonic. Okay, so once you Benedict doing, so once you doing the Benedict solution in the lab, so actually you check कि ये जो sugar है, either it belongs to aldehyde or ketone. So if they say, okay, 5C5H10O, 7 isomers, all of them are structural. Out of 7, 4 of them react with the failing solution, and they turn the failing solution from blue to brick red, and other 3, they don't. So you have to draw first the structure of 4 and then the structures of 3. They give you the, so 3 marks, I believe. So अब आपको वहां से समझ आ जाता है कि ये जो 4 कह रहा है वो 4 कौन होंगे, एल्डिहाइड्स, और फिर जो 3 कह रहा है वो 3 कौन होंगे, कीटोन्स. तो फिर वही तरीका जो अभी मैंने सिखाया है, put all carbon in one chain, draw the first the chain, then reduce the number of carbon in the chain and make the chain isomers. Then every chain isomer is treated separately to look at the position isomers, right? Okay, next is carboxylic acids. Again, for your kind information, the carboxylic acid, we know the position of functional group never ever goes from terminal. So it's again, iske position isomers nahi honge ya kam honge. Okay, the first one which I'm asking you to draw, C4H8O2. There'll be no position isomers in carboxylic acid, just like aldehydes, because their functional group also restricts at the terminal carbons. Please draw all chain and position isomers for C4H8, which are carboxylic acids. One, two, दो बने और दोनों chain ही है. There is no position. Yes, we can't make position isomers because, as I said and repeat myself again, that the position of CWH is we cannot change, right? Okay, so next is sorry. No, as I said, that'll be the same thing, na? That'll be the same thing. Sorry? No, वो तो फिर वही longest chain बन जाएगी. You want me to take this carbon off and put it here? Okay, now one more thing. I give a heading esters. So C4H8O2 सबसे ज्यादा जो tricky या मुश्किल होता है esters के isomers बनाने. C4H8O2. C4H8O2. Okay, please write down. Listen. Esters. Esters is a bit tricky. Now let me tell you how to make esters. I'll lead in this case. For the ester, I told you that you have to draw the functional group first of all. And then you know that there must be at least one carbon with this oxygen to be an ester. Okay? And then look, hydrogen on this side. Okay? Now, please pay attention. How many carbons here now? How many carbons? 4. So 2 carbons already I have placed. So this is 3, this is 4. So I'm trying to make a longest chain, okay? And putting all the carbons next to the oxygen. Okay, this is the first ester. Now, in order to make chain isomers, what I will do here, O, and instead of putting 3 carbon, 1 carbon is in the branch here. Now, these are the 2 chain isomers. Now, in order to make the position isomers are faster, you just have to move these carbons to the back side with CO. Left 2 carbon, then again move this to the back side. 3 carbon. I'm just taking carbons off from this side of the chain and taking it to the back side. I can't take this carbon off. Why? ये कार्बन ऑफ कर दूंगा तो वो हाइड्रोजन आ जाएगा ना, वो कार्बोक्सिलिक एसिड बन जाएगा, राइट? सो हाइड्रोजन मैं खुद नहीं लगा रहा, ऑक्सीजन के साथ होना चाहिए टू मेक इट एन एस्टर. सो 1 2 3 4 इन टोटल.
हाइड्रोजन कार्बन के साथ
This each be there.
Yes.
तो जब हम नीचे C सिंगल बॉन्ड C डबल बॉन्ड O सिंगल बॉन्ड O वाले जो बनाया है उसके अंदर तो कार्बन ऑक्सीजन एंड कार्बन का ऊपर है इंस्टेड ऑफ हाइड्रोजन कार्बन ऑक्सीजन.
No, हाइड्रोजन मस्ट नॉट बी देयर. मैंने कहा कि ये जो ऑक्सीजन होता है ना, इसके साथ आगे कार्बन का अटैच होना जरूरी है टू मेक एन एस्टर, because ester has this formula COOR. Okay, now they ask you, इसमें भी बच्चों they ask you this parents कि C4H8O2 का molecular formula है, it gives you 6 isomers and out of 6, 2 of them give effervescence with carbonate. So what do you understand? 2 carboxylic acid. And rest of the 4s are a sweet smelling liquids. They are best. So then you have to draw like this. Okay?
कार्बन के साथ H तो नहीं है बाकी अब दो
मैं खुद नहीं लगाया ना, वो तो आप लगा दें.
सारी इधर C डबल CO के साथ
Okay, thank you very much. We'll continue this stereo.